In this question, we're told, from the top of a vertical cliff 100 meters high, Paul sees a boat out to sea. The angle of depression from Paul to the boat is 43 degrees. How far from the base of the cliff is the boat? Okay, so in a question like this, first thing we need to do is draw it out. We're told the angle of depression is 43 degrees. So that if ever you're told the angle of depression, that is always an angle going down. Okay, so in this question it's 43 degrees. Now let's draw out the rest of it. So vertical cliff, so that straight line, vertical, are told 100 meters. Then our angle of depression going down is 43 degrees. So I'm just going to draw a horizontal line across here to show the 43 degree angle. Now the question says, how far from the base of the cliff is the boat? So imagine now your boat was here, and we want to find how far from the base of the cliff is to the boat. Okay, so let's mark in what we can here. Now, the red line here and the horizontal line up here, they are parallel. So which means this angle here is also 43 degrees because it's alternate with the other 43 degrees. Now, let's let's label our sides. Our right angle is here, which means this is our hypotenuse. The angle is 43, which means this is the opposite, and then we're left with the adjacent. And we're looking then for how far from the base, so we're looking for the red line, so let's call that x. Now, let's write TOA. Now, we can see here, my opposite is 100, the adjacent is x, what we're looking for. I have no information for the hypotenuse. So wherever there's a h, let's put a line through it. So we're going to be using TOA, which is tan. So tan of my angle, 43 degrees, is equal to my opposite over adjacent. So tan 43 is equal to 100 over x. Now, let's bring the x up. So tan 43 times x is equal to 100. So tan 43 is in front of x, so we'll divide by that. So x is equal to 100 over tan 43. Put that into your calculator now, and x is equal to 107.236 meters. So in this question, we'll actually round it to the nearest whole number. So we'll say x is equal to 107 meters. And that's my answer. Okay, let's have a look at another one. In this question, Siobhan is flying a kite on a string 20 meters long. The string, which is held 1 meter above the ground, has an angle of elevation of 30 degrees. How high is the kite flying above the ground? So in this question, we're told it's an angle of elevation. Now, when it was an angle of depression, it was going down. When it's an angle of elevation, it's going up. Like that. So let's draw this out. So if, let's say, her hand is here, and then she's flying a kite which is 20 meters, so a kite would never be going straight up, so that'll be at an angle. That is 20 then. It's 20 meters. We're told then the angle of elevation is 30 degrees. So this is 30 degrees here. We're looking then for how high is the kite flying. So we're going to be looking for this vertical here. Okay, let's label our sides. So we have our hypotenuse, our opposite, and our adjacent. That's right, so TOA. So again here we're looking for how high, so we're looking for the opposite, so let's call that x. And we can see now we've no information for the adjacent. So wherever there's an A, line through. So we're using so it's going to be sine. So we're going to have sine of our angle, so sine 30 degrees is equal to the opposite over hypotenuse. So sine 30 degrees is equal to x over 20. Bring the 20 across. So now it's going to be sine 30 times 20 is equal to x. So now let's put that into the calculator. And that is equal to 10. So 10 meters. But be careful in this question. We're also told that the string which is held 1 meter above the ground. So here is 1 meter. And then x was 10. So between here. So then add these together now. So 10 plus 1 is 11 meters. And that's my answer. Any questions, please leave in the comments. Thank you.